Hi, everyone. It's great to have you here. I'm Teresa Yunkin, and I'm deeply committed to bridging the gap between healthcare and technology, making it accessible and impactful for all. You'll find me here helping healthcare leaders stay ahead of the curve when it comes to new technologies. And as an informaticist, my job is to bridge technology concepts and business operations. So, whether you're struggling with data initiatives, trying to make informed decisions about new technologies, or dealing with the constant changes in the market, I got you covered. Welcome to my fall series where I am covering my most frequently asked questions on AI. So, this week's question is, how does AI work? I want to start with a very high level history of AI. In 1950, we have Alan Turing's vision of a machine that can simulate any human intelligence, leading to the Turing test concept. And then in 1956, building on that type of work, a group of scientists and mathematicians got together and they called it the Dartmouth Workshop. And that's where the term artificial intelligence or AI is coined. And then early experiments like ELIZA and Shirtaloo, those showcase the potential of AI. In the early 70s, early 80s, we have a time called an AI winter. That means that people aren't investing in AI as much. That happened because there are these hype cycles where people were saying it could do anything. That crashed into the reality of having technological limitations, and that produced periods of skepticism. People were writing papers about how AI was faulty, it didn't live up to its potential. That reduced funding because people were overpromising results, but there were these great technical limitations. Once we got past that in the mid 80s, there was another AI winter that happened right around 1987 that went on for a couple of years. And then in 1993, we see the resurgence of AI with neural networks, the introduction of deep learning and convolutional neural networks. This is what some people will call AI's new golden age. In 2010, AI starts to really grow. We've got these new techniques and algorithms, and the public becomes aware of AI when IBM Watson wins Jeopardy. Do you guys remember that? It was based on this whole idea of machine learning. That's really the core of modern AI, this machine learning. That introduced supervised, unsupervised, and reinforcement learning. And I'll get into that just a little bit later. Next, this core of modern AI is natural language processing, and that allows algorithms to help machines understand and generate human language. Lastly, we've got this era of advanced computer processing, and they call it computer vision. So, this is where machines can interpret and make decisions based on visual data. In healthcare, it's looking at our radiological studies and being able to make decisions based on visual data. I want to call this out as part of our ethical responsibility is all this computing power takes a lot of energy. So there are efforts right now focused on AI's role in sustainability. Because it's got such great power, it can help us leverage AI for climate modeling, for conservation, and for developing newer green technologies. The future of AI I see more quantum computing happening. We're starting to see more artificial general intelligence. AGI means that it's computer programming, and these models are starting to think like humans do. It's getting very exciting, and it's going to be great to watch. And I'll be bringing you all the great stuff as it happens. Artificial intelligence encompasses computer systems that can perform tasks that would typically require human intelligence. These tasks include problem solving, understanding language, and recognizing patterns. We'll begin with the broad categories of AI here, and first up is supervised learning. That's where the mathematical processes that support this kind of AI are usually regression, classification, and predictive analytics. Our real world use case here is Apple's enhanced Siri. It uses deep neural networks, recurrent neural networks, and the type of AI, again, is natural language processing or NLP and speech recognition. How does this work? Well, you have to have these inputs, and the inputs are voice commands, questions, and prompts. The learning models are trained on diverse speech data sets. Now, the output, you're going to get the accurate detection of and conversion of voice to text And lastly, the benefits of this application are the improved user interactions. So we get multilingual support, we get accessibility features, which is very important when it comes to DEI, inclusion criteria when it comes to using these new technologies. The next one I want to talk about are unsupervised learning models. Now, these models are trained on data where only the input is provided and the algorithm then finds patterns or relationships. The real world use case for this is Netflix. They've got this recommendation engine and it's constantly evolving if you haven't noticed. One of my favorite things is to get a new suggestion and it turns out to be really good. They use the algorithms types of clusterings. For example, k-means is one of them, and matrix factorization is the other type. These are called recommender systems. So, what would our inputs be? It would be user viewing history and content metadata. That model will cluster and look at different dimensions of that data, and it'll reduce some of that redundancy in it. And that's how you get those great personalized movie and show suggestions as an output. And the benefit for that application is increased viewer engagement and a tailored user experience. The last broad category of AI I want to talk about today is reinforcement learning. Reinforcement learning involves an agent learning by interacting with an environment, and that agent receives rewards or penalties for the actions that it takes. The verbiage around this is a little bit different because we're talking about real world ingestion and processing of data as it's happening and adjusting and optimizing in the moment. So, those algorithm types that are used are called deep Q learning and proximal policy optimization. The types of AI I'm talking about are autonomous systems. Waymo is one of my favorite ways to get around when I'm here on the West Coast. When you hear the word state in relation to AI, it's talking about the environment that the AI is working in. So the state for the Waymos is surrounding vehicles, pedestrians, traffic lights, road signs. It also works on actions, these real time actions. So, what are those? They are changing lanes, accelerating, braking, turning. What's the reward? The reward is safe navigation without incidents. What are the benefits of this application? We have safe autonomous driving, reduced traffic incidents, and efficient route planning. So, just a quick story. The first time I was in a Waymo and it took a left-hand turn, it felt like such a harrowing experience. I had to remind myself that number one, the Waymo is taking in a lot of data, including speed, velocity, the cars that are coming the other direction. It knows how fast it will accelerate. There's no hesitancy in what the Waymo is doing. It's thinking and processing all the time. Unlike us as humans, when we're going to make a left hand turn, depends on if I'm wearing my right glasses today, or if I can judge how far the cars are away and how quickly that they're coming. It also is what kind of car am I driving? When I put my foot down, is there a little bit of lag while the engine combusts and my car takes off? The Waymo has a way of calculating all of that all at one time. And it includes all these variables. So that left hand turn where I would think I wouldn't do it, the Waymo will do it. Now, while both large language models and generative AI involve creating new content based on learned patterns, the main distinction is in their scope and their specialization. So, if you've ever wondered how Siri, Alexa, or Google Assistant a- answers your questions, it's because they're using large language models, LLMs, and that is a type of artificial intelligence that's trained on vast amounts of text. So LLMs excel at tasks like answering questions, writing essays, helping with homework, or even creating poetry. The primary purpose of these LLMs is to understand and generate human like text on the patterns it has learned. So OpenAI's chat and stands for generative pre-trained transformer. That's a prime example of a large language model that's being used on a wide scale. Next, I want to talk about generative AI. Now, this is a little bit broader. And these generative AI models are designed to create content from text to images to music. So it's a broader range of content that it can create. And they've learned from data patterns and produce new, unique content. The aim at these models is creation rather than just prediction or classification. Generative AI models learn the patterns and the structures of the data that they're trained on, and then they do produce new original content based on that training data using the dual system of generative adversarial networks or GANs. What that means is that the algorithm comes in two parts. One part is to create content, and the other is to critique and to refine. My example here, if you look up, you'll see that on the left is a painted picture of Rembrandt. On the right is a gentleman who wanted to look like Rembrandt and used AI to transform his features and his face into being something very close to Rembrandt. So he looks very close to him. So it's not an exact copy, but it takes the original picture plus the picture that you're going for and it creates something that's brand new. So we've got artwork of this face of a person who doesn't really exist. We're going to talk about ethical considerations again about AI. Because we can do things like this, we have to be very careful about deep fakes. And it's not just being able to recreate a face, it's the ability to speaking and speech with the voice of the person who is doing it. So if you remember back in the spring, there were tons of songs that were coming up by artists that never recorded songs before. It's a little strange, but as an ethical consideration anytime you're using this type of generative AI, you need to keep in mind that you have to be responsible. In our rapidly evolving world, the convergence of your business and technology holds boundless potential. And the future is brimming with opportunities as we've journeyed through the intricate landscape of AI. It's evident that AI is going to play a pivotal role in all of our businesses. And with AI's capacity to revolutionize workflow, to streamline operations, and to address some of our most pressing global challenges, staying informed is more vital than ever. And as leaders, the onus is on us to harness these advancements for the greater good. I'd encourage you just not be a spectator. Let's be the architects of this transformative era. Dive deeper, ask questions, and collaborate. Together, we can shape a future where technology and our businesses are seamlessly intertwined for the good of all. Join me in this mission. Reach out. Let's discuss how I can help you lead that change. We can do it and we can do it together. Thank you so much for joining. I will see you guys here next week where I'll be answering more FAQs on AI.